Hello everyone, I'm Said and welcome back. Today we're diving back into logarithms with some practical practice problems. Don't forget to hit that subscribe button so you don't miss any lessons. Let's get started. Number 1, if log of 7 is a, find log of the cube root of 3.43 in terms of a. First, notice that 3.43 can be written as a fraction. Means 3.43 equals 343 over 100. Now 343 is a power of 7 because 343 equals 7 cubed. Also 100 is 10 squared. So 3.43 equals 7 cubed over 10 squared. So this expression becomes log of the cube root of 7 cubed over 10 squared, or log of 7 cubed over 10 squared to the power of 1 over 3. Now using the power rule of logarithms means we can bring the exponent 1 over 3 in front of the logarithm. So we have 1 over 3 log of 7 cubed over 10 squared. Now we use the quotient rule, means 1 over 3 times log of 7 cubed minus log of 10 squared, right? Now using the power rule again, we have 1 over 3 times 3 log of 7 minus 2 times log of 10 is 2 minus 2. And we know that log of 7 is a. So we have 1 over 3 times a, 3a minus 2. So the final answer is this. Number 2, evaluate log of 2 plus log of 3 plus log of 4 over log of 2 plus 1/2 log of 6. First look at the numerator. Log of 2 plus log of 3 plus log of 4 equals log of 2 times 3 times 4 is 24 over log of 2 plus 1/2 log of 6 equals log of 2 plus log of 6 to the power of 1/2. Log of 6 to the power of 1/2, or log of the square root of 6. Right? So we have log of 24 over log of 2 times the square root of 6. 2 times the square root of 6. Now here is the important observation, because 2 times the square root of 6 squared equals 4 times 6 is 24. That means log of 24 equals log of 2 the square root of 6 squared. Now we use the power rule, is 2 times log of 2 the square root of 6, right? So this fraction becomes log of 2 times log of 2 the square root of 6 over log of 2 the square root of 6 equals 2. So final answer is 2. Number 3, evaluate log base 15 of 5 squared plus log base 15 3 times log base 15 of 75. This problem may look complicated at first, but the key is to use the relationship between 3, 5, and 15. Let's define x equals log base 15 of 3 and y equals log base 15 of 5. Since 15 equals 3 times 5, so we can take the logarithm of both sides with base 15. So we have log base 15 of 15 equals log base 15 of 3 times 5. Using the product rule means log base 15 of 3 plus log base 15 of 5. So log base 15 of 15 is 1 equals log base 15 of 3 plus log base 15 of 5. And as you know, x equals log base 15 of 3 and y equals log base 15 of 5. So x plus y equals 1. Right? Now simplify log base 15 of 75. As you know, 75 equals 3 times 25, right? Or 3 times 5 squared. So log base 15 of 75 equals log base 15 of 3 times 5 squared, right? Using the product rule and the power rule, we have log base 15 of 75 equals log base 15 of 7 plus log base 15 of 5 squared, or log base 15 of 3 plus 2 times log base 15 of 5. As you know, log base 15 of 3 is x and log base 15 of 5 is y, right? So log base 15 of 75 equals x plus 2y, and we know that x plus y equals 1. So we have equals x plus y plus y. X plus y is 1, so we have 1 plus y. So log base 15 of 75 is 1 plus y. Now substitute everything into the original expression. Log base 15 of 5 squared is y squared plus log base 15 of 3 is x and log base 15 of 75 is 1 plus y. So we have y squared plus x times 1 plus y. Let's expand y squared plus x plus xy. From x plus y equals 1, we have x equals 1 minus y. Also, xy equals y times x is 1 minus y. So xy equals y minus y squared. So we have y squared plus x is 1 minus y plus xy is y minus y squared, right? So y squared and negative y and positive y cancel each other out. So we have The final answer is 1. This is a good problem.